and you're in the mud and you can't come up, and you start to breathing, you're breathing quite heavily, and you've got a contents gauge to tell you how much air you've got left in these scuba tanks, but it's so black you can't see how much you've got, and you're breathing quick, and it gets to a point where you start to think, I'm not really comfortable down here, and I wouldn't mind coming out here, but you can't. Then things start going through your minds like, am I going to get stuck here? Is this where I'm going to end my young days, because I wasn't very old then? You're frantically swimming about, trying everything. You put your hands up and zoom, up you go. You've found the hole and out you come. But, that's not that good.
That was David Harrison Beckett. He's a now retired deep sea diver. We were speaking to him because this podcast is about the increasing amount of work that needs doing in extreme environments and how robotics and AI might be able to help us out. David had plenty more tales which we'll share later, but for now, shall we stop this rather dramatic music and get on with the show? Hi, I'm James Ewings, and I'm here to present the first in a series of podcasts from Innovate UK. Unsurprisingly, it's a podcast about innovation. Specifically, how it helps solve the challenges that we face in our day-to-day lives. This might be about how our medicines are made, or reducing range anxiety by helping electric cars go further. Solving these challenges presents business opportunities. So if you're interested in tech and innovation, or you're a business that's looking to grow and want to find out what's out there, then this is definitely the podcast for you. We're going to start by looking at the state of play in the robotics industry. We'll look at where the tech is, what the challenges are, and perhaps what's hindering progress. After that, we'll get stuck into the commercial opportunities that exist for companies that can solve these problems. Then we'll take a look at potential future applications of the tech that's being developed now. And of course, we can't talk about robotics without talking about the old favourite, are robots going to take our jobs? So what do we mean when we say extreme environment? Well, of course, I could have a stab at it, but why don't we ask an expert? Andrew Tyre is Deputy Director of Robotics and AI at Innovate UK, and he explains it much better than I could.
You could put robotics into most situations, be it domestic situations or industrial situations. So that could be, deep mining, it could be deep under the sea, nuclear decommissioning, or up in space even. So these are areas where there's great opportunity, where there's an economic need, but also where you wouldn't normally want to put people.
Before we go any further, there's somebody I should introduce you to. He had something insightful to say about everything we cover here, meaning he pretty much appears all the way through. So...
Hi, I'm Rich Walker. I'm the Managing Director of the Shadow Robot Company. We're a UK SME specialising in the design and development of robotic manipulation technology. We build hands for robots.
Andrew just mentioned nuclear decommissioning, and obviously that's one of the last places you'd want a person to work. Well, we spoke to Viridian CEO Kim Jarvis to get some idea of the scale of what needs doing. So the first question we asked was, is it just old power stations, or are there more places where this kind of work is needed?
There are a number of areas actually. Obviously the main focus is really the future decommissioning of our operating power stations, and also the decommissioning of the power stations which preceded those, which are on a number of sites around the UK. But we also have a number of what we might call legacy sites right across England, Wales and Scotland. And those are the sites that were really responsible for the early development and experimental work with nuclear power and, of course, nuclear weapons.
And then Kim went on to tell us about the process that's applied to these kind of sites.
The starting point for that is really the characterisation of surfaces and equipment and the buildings themselves to demonstrate that they are either not contaminated and therefore can be recycled, or that if they do have radioactive contamination on them, that they can then be either stored or disposed of appropriately.
You might not believe it, but most of this work is still done by people.
There are very few automated processes, particularly for the first stages where the characterisation of the materials is taking place. That's usually a very manual process, so that would involve a person going into a site and taking samples. Those samples are then sent off to laboratories around the country. Then the data comes back and a decision can be made about what happens.
So the next thing we wanted to know, of course, was what are the dangers that people are facing in these situations? We were looking for a kind of sci-fi answer, like people melting or their heads exploding because they'd stayed in the radiation for too long, but Kim kind of set us straight on that one.
They wouldn't be permitted to. There are extremely rigorous safety procedures in place, and that's because radiation of different types affects living matter. So whether it was a person or an animal or a plant, radioactivity interacts with the cells, in fact destroys those cells. So we always work on the principle of as low as possible.
So at this point we're thinking, if it's this dangerous, why aren't we using more robots already?
The technology's not really been there. It's only in more recent years that we've had fairly sophisticated, remotely operated vehicles.
So you'd assume it's all systems go. Well, not quite.
So there's a limit to the payload remotely operated vehicles can carry. They also require electronics to drive them and control systems, and those systems are not tolerant to radiation.
Rich Walker adds a little more to this.
You do run into this material science problem. And there isn't really a kind of master catalogue of all the use this material for that, use this over there, do this with that.
And as a result,
Making electronics that's radiation tolerant or resistant is difficult and expensive.
back to Kim.
So we have to have systems that can be remotely deployed, or that their control systems are outside of the radiation fields. If we send devices, tools on remotely operated vehicles into high areas of activity, they may become so contaminated that we can't ever take them out again. They would then become part of the waste stream themselves and would be disposed of as radioactive waste.
Rich had his own story.
There's a recurring thing about Fukushima where there's graveyards of robots. People have sent a robot in and it's worked for 90 minutes and then died. Great, now I have to send another one in.
Andrew reminds us that it's not just robots.
You end up with several times more waste just from wearing suits and doing things than you would be with actually the things you chop up.
And as if that wasn't enough,
There's obviously a cost-benefit analysis done to decide whether it's worth sending them in, so they're sent into the most challenging areas to address the most challenging problems.
and when we talk about cost, we mean cost.
But those pieces of equipment may be 100,000 to £500,000. They have a job to do, and then that's the end of it.
If you don't know, an ROV is a remotely operated vehicle. And Kim had one final thing that she mentioned about how they weren't quite ready for what she needed at the moment.
The robotics are great. They can access areas, but they need to carry appropriate tools to do something when they get there. Being able to get there is not enough. They need to be able to carry various radiation detectors, radiation mapping devices and sampling tools in order to do a useful job when they're put in somewhere.
This issue around tools and dexterity takes us nicely back to divers, who have almost the opposite problem. They have the dexterity to do the job, but the environment around them makes it a challenge, and in some cases impossible. Diving's interesting because it's an industry that's been using robotics since the 70s. So divers have a great deal of experience of the technology's benefits and its limitations. And of course, they definitely have an understanding of what extreme means. With this in mind, we took a trip to the Underwater Centre in Fort William, Scotland. It's a hub of all things, well, underwater. They train divers, ROV pilots, and they also host subsea equipment testing. So they have a great overview of all aspects of underwater work, with no particular bias towards humans or tech. The first thing we did was find out what challenges divers faced. A big part of diving is the atmospheric pressure change when at depth, and saturation diving is a process that deals with this. Operations Director and Head of ROV Training, John McClellan, was kind enough to show us around and bring us up to speed. Just listen to what a dive has to do before they even get in the water.
So this is the entry to the transfer lock on the saturated system. This is the closed bell. Entry to the closed bell is to work site is through the bottom of the bell. And once the guys are under pressure, they'll transfer to and from the main chamber via this transfer lock. So the door will open, it locks onto this facing. The trunking will be blown down to the same depth, enabling the doors to open and for the divers to transfer safely into the transfer lock. And then once the bell has been removed, new offshore, the next set of divers should come out under pressure, transfer back into the bell will be locked down, launched to seabed, and they'd start their work shift. Just like going to and from work.
Uncanny. Just like my commute. The reason they go through this rigmarole is to avoid the dreaded bends, which David Harrison Beckett, you might remember from the start of the show, explains.
The bend is caused by not giving the nitrogen bubble time to go back into liquid, and it can get stuck in any of your joints or your brain or your spine, If you get it in the brain, obviously that's really serious. If you get it in your spine, that's not very good.
No, not good at all. Well, obviously there are the bends, but people generally accept that diving is a dangerous occupation. But how dangerous is it? Does it affect long-term health? Well, we decided to go and see Dr. John Ross. He worked with the University of Aberdeen to conduct a study into the long-term effects of diving. Do you know what? He didn't find much.
There were some studies in Bergen that identified white matter lesions in the brain and in the spinal cord, and these were attributed to diving. But there was no real control to the observations.
Without proper controls, it's difficult to categorically state that these lesions were related to diving. So John made that part of his study.
We looked for these white matter lesions in MRI scans, and we did see that you were more likely to have one or more of these lesions if you were a diver. But one or more, classically you'd be worried about these things if you got them in large numbers. So again, that's the only objective identifiable thing that I've seen that might be associated with diving.
Aside from this point, John feels that most of these conditions are related to general lifestyle. He gave an example that's on a lot of people's minds at the moment.
Shift work is increasingly being observed as not being terribly good for you. If you alter the body clock in any way, it has profound effects. And if you put somebody on 2 weeks of shift work, at the end of that period, they will experience a phenomenon which is very close to jet lag. They get forgetful, they get a bit grumpy, disturbed sleep. And it's clear that divers coming off saturation also get this. And the longer that they're under, the worse it'll be, and it lasts for about 2 weeks. And if you ask them about it, it's classic jet lag. That will be attributable to diving. That will be picked up in people's psyche as being a neurological effect of diving, when in fact the more logical explanation for it is the neurological effect of shift work.
So we've looked at diving itself and whether that has any long-term effects. But most of the divers were concerned about industrial accidents. So it's more like the kind of problems you might encounter at a building site. This is a big thing because it's something that applies to things like wind turbines or other heavy machinery that's used in those extreme environments. David Harrison Beckett recounts this story from one of his dives in the North Sea.
We were working on one project where we were just had an underwater hammer, and we were knocking these piles in this manifold to make it stable. And something happened with the hammer, and the diver swam underneath the hammer to look up and see what was happening. And at that moment, the hammer released itself and came down and chopped this guy's arm off. And we had to put him back into the chamber, obviously under pressure. And we had to fly a doctor out from Aberdeen who came on board the vessel. And we blew him down to 350 feet in 20 minutes, which is really unheard of. And he then had to operate on this guy, cut his arm completely off, and then stay with him for 2 weeks while they stabilised him and then decompressed him.
Clem, who conducted the interview, asked how he was when he came out.
He wanted to give me a cuddle, but he only had one arm.
If you want to hear more of David's stories, he's written a great book about his diving years. It's called The Loneliness of the Deep Sea Diver, much of it from the early, dangerous diving years. Fortunately, things have got better, as Alf Ledbitter, another very experienced diver who teaches at the Underwater Centre, says.
We do roughly the same dives as what we did then. However, because of increases in training, we turn out much better trained divers now than what we used to.
So it's pretty clear. As cool, calm and collected as these divers are, these extreme environments are still very dangerous. And as with nuclear, there are very definite limitations on what the human body can tolerate. After all, some oceans are nearly 11,000 metres deep. Divers have been working with ROV since the 70s, and despite some initial apprehension, they seem to be rubbing along together quite nicely.
They're very good to dive with, they're very safe, they keep an eye on people. From a safety point of view, they're excellent.
And like every diver we spoke to, he had a terrifying story about it. This time about an unfortunate diver
who was 39 minutes on the bottom with no gas supply. If there hadn't been an ROV there, I'm pretty sure that the diver would have ended up being killed. But because of the circumstances, cold water, your body shuts down. He was revived just like that in the bell.
John from the Underwater Centre reminds us it's not just safety.
You're not restricted by depth with an ROV.
Or depth.
A modern work-class ROV can do maybe 80 to 90% of what a diver can do, but obviously can do it at prolonged periods of time.
Now, You might be thinking that this is starting to sound bad for the divers. Well, don't worry, we'll be looking at that a bit later. As for the ROVs, it's not all plain sailing. Or should that be diving?
ROVs are only as good as the individual that's operating them from the surface. When you're operating something that's 3,000 metres below the surface, you maybe aren't as aware of the surroundings. There are huge, entanglement risks, and that's always a risk to an ROV.
So how do we get this technology to a point where it's as aware or responds as well as humans do in these situations?
Autonomous vehicle,
That's one that doesn't need a pilot.
Technology is changing daily. Interesting times for subsea robotics, I would say.
So to learn more about how autonomous vehicles are changing rapidly, we went to the National Oceanography Centre in Southampton and we spoke to
Terry Sloan. I'm the Managing Director of Planet Ocean Limited.
And the first thing he wanted to do was clear up misconceptions about what robots actually are.
Well, the public perception of robotics, I suppose, is what most people see most of the time in the news and the media, which is getting robots to do mundane things which humans don't want to do. Whereas in our industry, as you can see around the site here at Southampton, we're putting robots where we can't go. So that's a slightly different thrust. And our robots don't look like humans, they are robotic machines.
Rich Walker talked about this perception more broadly.
The fun thing about robotics as an industry is we aren't an industry. We're a technology pool. What we develop as robotics people disappears as soon as it gets used. You don't buy a robot to do your vacuuming, you buy a vacuum cleaner that has a load of robot technology in it to make it wander around your house and do the vacuuming. So we have this interesting kind of problem as a field that no one sees us. The biggest employers of robot people are all companies that don't have robot in their name.
Returning to sea robotics, the NOC's Associate Director of Enterprise and Research Impact, Kevin Forshaw, reminds us of just what these machines have to tolerate.
Absolutely crushing pressure. You're over 600 atmospheric pressures. And that's why it's practically impossible to put people in that loop.
A point reinforced by Terry.
The challenge for us is very much making these things robust to work in the very harsh environments.
Which, believe it or not,
are far more extreme than space, really, because space you're going from 1 atmosphere to no atmospheric pressures, and deep ocean you're going, 1 to 600 plus.
And why would you bother going anywhere so challenging? Russell Wynne, who's Chief Scientist on the NOC's Marine Autonomous and Robotics Systems, or MARS, explains,
if any organisation, company, etc. wants to go and do anything on the seabed, it has to conduct an environmental impact assessment.
Someone's got this covered, right?
Yeah, one of the shocking statistics is that the Moon, Mars, it's the old cliche, we've got better maps of those environments than we do our own continental shelf around the UK.
And this affects a lot of organisations.
If you want to put in an offshore wind farm, if you want to do any other sort of activity that interacts with the seabed, you've got to go through a whole process of getting data to prove that you're not going to impact it. And the first thing that anyone always wants is a map. And generally people have to go out and pay to get their own area of interest mapped in detail because there aren't any pre-existing maps. So instead of every individual and every organisation that wants to operate in the marine environment having to collect their own map, which is not at all cost effective, if we had an up-to-date map for the UK area, it would just be so cost beneficial to the maritime sector. I think with the new marine robotic technology, it's going to become affordable quite quickly.
Russell told us a story about how surveying helped us discover something that we didn't even know was on our doorstep.
A few hundred miles southwest of us, on the very edge of English water space, is a canyon, and part of that canyon has been designated one of the new marine conservation zones, and it's absolutely spectacular. And the British public had no idea that in England we have huge cold water coral reefs, a canyon that's host to blue whales and broad-billed swordfish and blue sharks and this whole wealth of marine life, all within English waters. And we managed to image that with our marine robots, and the quality of the imagery we got has really changed the public's opinion about that particular bit of the ocean that most people didn't even realise we had within our own waters.
Now you can actually see this incredible footage on the NOC's YouTube channel. We'll be posting a blog with all of the links to everything we mentioned in the programme, so you can check them out in one place. Back to Russell, and the NOC are making progress with
the new AUV, the yellow submarine that we've developed, which is the one that's known as Boating McBoatface.
Long story short, they called the big boat the David Attenborough, and this little boat Boating McBoatface. And it has
a much longer endurance, it's got better engineering efficiencies, more efficient sensors, better batteries, etc., etc.
Okay, so it's all moving in the right direction. But what about operating these things under the ice? Kevin from the NOC outlined what they're working on.
Particularly the Pine Island Glacier and the South Pole, and that again is a hazardous environment. We need to get there because we've got to understand how the warming seawater is melting the ice from underneath.
And the problem?
How do you put a human in that loop? You can't. It's practically impossible. So that again was another big driver for us developing marine autonomous systems and marine robots to go and capture the data that we need.
We spoke to Stephanie Henson, who's conducting a number of marine research projects, all of which would benefit greatly from further development in the field.
So I think in the next 20 to 30 years, what I really hope is that we can get more information in very hazardous environments. For example, in ice-covered regions. Right now, the technologies we have, the underwater autonomous vehicles, are limited in what they can do under the ice. In particular, that interface between where the ocean meets the ice, it would be very useful to be able to get close to that, which we currently can't.
As well as access issues.
There's also a lot of information on the biological side that we can't get. So although the sensors can tell us about the basics of what's living in the ocean and the types of particles that are there, we can't get any information about the rates or the functioning of the ecosystem. And so in the future, I hope that we can get some more information on that.
The trouble is, and as Russell says,
it's really, really tough. People are very familiar with the Mars rover, and actually the way in which we're approaching the challenge is not too different, but I would say going under ice or to the deepest parts of the ocean is even harder because you have no direct communications.
OK, so let's unpack this a little more. Here's Kevin again.
Technically, the challenges are really around powering and communications.
The power issue was a recurring theme with almost everyone we spoke to. Interestingly though, Russell explains that they're looking to other industries to supply that technology.
The marine sector generally is not in the game of driving forward battery technology, so we're very much pulling through technology from things like unmanned cars and other platforms.
And as far as communications go,
if you're under the ocean, then really you're communicating via sound. So sound you can communicate over very long distances but at a very low bandwidth.
This means that the control of the vessel and collection of its data are difficult. Russell adds a third vital area to be addressed.
The other one is intelligence. So at the moment our vehicles are relatively dumb and they're operated by intelligent pilots. What I'd like in the future is to have more intelligent vehicles that could be operated by dumb pilots.
And he goes on to say,
for me the two things come hand in hand. There's two big developments that I see going forward, batteries and intelligence, because if you improve the batteries and you improve the endurance, then there's the potential to have less communication with the vehicle if the vehicle can continue to do what you want it to do in an intelligent way.
And all these problems need to be solved
on a fraction of the budget that the space industry has.
Here's Andrew Tyrer again, outlining where we are with AI.
Artificial intelligence in the robotics domain is really an enabler. So if you think at the moment, most robotics are tethered back to a person or a thing most of the time. Even in a factory environment on a production line, there's a degree of sensors and actuators. And actually, if something goes wrong, the default thing is to stop. And then a human will come along and repair those things. So if you have robotics with artificial intelligence in it and allows that robotic system to make its own decisions, it gives it a bit more freedom to operate. What it allows you to do is assess its own conditions whilst it's there. So if you're down on the seabed and you're trying to repair something, then if it's an individual person, they think how to repair that. A robot will just do what you've told it to do. But actually, if it can assess its own situation, then it could do things which maybe a human couldn't even do, but also it means it would save you so much time and money. So artificial intelligence is really important, and autonomous elements of that are key. And if you don't design it in the beginning, it's very hard to retrofit. The maturity of the software and the systems is only really coming into force now where you could commercially apply those things.
We've looked at the state of play in a number of extreme environments, but before we go on to the commercial opportunities, there's one more area I'd like to cover: wind turbines. These face a number of challenges that you might not even be aware of.
There are hundreds of thousands of tons of dumped munitions on our seabed as a result of the last two wars. The first thing that any offshore wind developer has to do is what they call a UXO survey, an unexploded ordnance survey. Because if they start piling to put a wind turbine in and there's some unexploded ordnance in the way, you get a very nasty explosion.
People forget that these things are connected to the mainland, as Kevin explains.
Cables need to be laid on the seafloor, cables need to be inspected. So whether it's an offshore wind farm providing the power to the shore, or whether it's how countries literally join each other up.
Now this is an interesting point. There's a misconception that the internet is delivered through the air, but actually there are hundreds of fibre optic cables that run through deep sea connecting everything. If this is something you're interested in, there's a great video that Vox.com did that explains everything. As I mentioned, we'll link to all of that stuff in our blog. As impressive as it sounds, Kevin outlines some potential problems.
When we do get transatlantic cable breaks, we have a severe economic impact because, obviously people cannot communicate. People trading stock and stock exchanges do not get real-time information. So I think cable inspection is another big important area for marine robotics.
And in case you're wondering why someone who deals primarily with marine research is talking about wind turbines, well, there's a technology transfer opportunity that he's very interested in.
In terms of target recognition, target acquisition, we're looking for species, possibly minerals. The fact that an offshore wind developer is looking for unexploded ordnance is no big stretch for the current technology solutions we would employ.
James, from ASV, a company who use autonomous vehicles for hydrographic surveying, explains how autonomous vehicles can be used to help with wind turbine maintenance and inspection.
We are trying to work more and more in the offshore wind industry. It's a very new sector for us, and it's been very dominated by doing things in traditional methods because of the dash to reduce the cost of energy. And therefore the lower risk of doing it with a traditional manned survey craft has been beneficial. We are embarking now on a number of projects where we're going to be introducing autonomous systems into the wind farm. So there'll be one going in there doing inspection and maintenance, so using one of our 7-metre unmanned vehicles and an ROV that's traditionally tethered off something like a dive support vessel which is manned. This will be tethered to one of our unmanned vehicles, controlled from the shore, and be able to go in and do some of the inspections that maybe you'd have to have got divers in to do previously.
So why is this an improvement on existing methods?
Because one of the risks are, if you bring a vessel close proximity to a wind turbine, what happens if it drifts into that wind turbine? Could it damage it? Traditionally, the vessels that would be deploying this technology could be quite large because of the manning requirements. They would have to be positioned in such a way that if they did lose power, they wouldn't hit the wind turbine, which restricts your ability to inspect it. Because we're going to be doing it with a much smaller platform because it's unmanned, and you remove all of those things you need to have people on board, really silly things like toilets and showers and stuff like that you have to have if you're going to be offshore for a number of days. We don't have any of that. It means that we can fit a lot more stuff into a much smaller package. If we did lose power for any reason and did collide with the wind turbine, it would be a much smaller risk because we're talking about something that may be 4.5 tons, not something that's sometimes thousands of tons.
Moving away from autonomous sea vessels, Kevin Lynn from Perceptual Robotics is looking for a drone camera solution to what's quite a laborious maintenance problem.
Sort of ground-based inspection with cameras is really common. What they end up doing is 2 technicians go out, go to the base of the turbine, lock it off, sort of pitch the blades so it's no longer rotating. Rotate one, they call it bunny ears, where they put two blades up, 1 blade down, and they sort of look up and down.
Well, you get the idea. And Kevin's proposed solution?
From our perspective, we'd like to maintain that capability and in future sort of go beyond it and be able to operate outside of the environment that humans are comfortable in. And so it opens up new regimes for inspection, but yet it also means that less people are having to be subjected to, I guess, that sort of environment.
I think we've pretty much covered everything we need to. So when we come back, we'll be looking at the commercial opportunities in these areas. If this was any other podcast, this is where I'd be trying to sell you a mattress or some kind of revolutionary shaving solution. But as it is, what I'd like to talk to you about is the Industrial Strategy Challenge Fund. If you go to innovateuk.gov.uk, you can find out all about the funding opportunities that we're offering. They're all based around the kinds of challenges that we talk about in this podcast. Right, self-promotion over. It's time to look at the commercial opportunities that exist for businesses that can address the issues we looked at in the first half of the show. It's all very well talking about what great things can be done with robotics and AI, but is there actually a market opportunity? Is it even worth a business getting involved? Well, as Rich Walker points out, when you're talking about safety and extreme environments, then you're pushing on an open door.
To some extent, it can be a really, really easy pitch, a really easy sell, because when you say to somebody, this technology can improve your safety record, your safety culture, your approach, people go, okay, yeah, we will be looking at that technology. We can't not look at it, really.
Companies may well be keen, but Andrew Tyrer points out that investing in this disruptive technology isn't a straightforward decision, and in fact,
it's risky. People don't like taking risks. So, if you don't need to take that decision because you've got a business plan that works, or it might be that it's disruptive to your marketplace. So if you've already got a market and you're selling those items into that marketplace, then you might want to innovate and get ahead of your competition, but you don't want to totally disrupt the market, because that means you might damage your own business plan.
Kevin from the NOC says that economic pressure can actually be the catalyst for development and commercialisation.
You've probably heard quite a bit about the oil and gas sector being quite depressed, on its knees at the moment. That is true. That's actually helped us, because several of the oil and gas companies we're engaging with have stated targets to reduce inspection costs. So a marine autonomous systems survey method could be as low as 4% of the cost of ship-based alternatives. So it's that driver, really that cost driver, that's dragging marine autonomous, marine robotic systems into the attention of senior executives in many offshore industries, oil and gas, offshore renewables, emerging sectors such as deep sea mining.
Back to Kim at Viridian, and she worries that with the nuclear sector,
the drive isn't there to do that development because you can't commercialise it.
She further explains that timescales can negatively impact investment in this area.
For the decommissioning of our currently operating power stations, that programme won't begin for another, 7 years, maybe slightly longer than that. So we need to be in preparation for it, because you can't suddenly produce all the technology you need in 7 years' time. So we have to have a lead-in time, but you also have to accept that during that time, the commercial side of it is not really in place, because the systems aren't being required on the sites yet. That's not going to happen for several years.
Yeah, okay, I get it. There are hurdles. But let's be clear. There's definitely a market there for companies that develop solutions in this sector. Here's Director for the National Centre of Nuclear Robotics, Professor Rustam Stolkin.
Cleaning up the UK legacy nuclear waste is expected to take 120 years and cost as much as £220 billion. A significant part of that must be done by robots, because the materials are too hazardous for humans. If we can develop novel robotics approaches to solving that problem, then they can also be applied to a worldwide market of order 1 trillion, which can have great benefits to the UK economy.
So, some big numbers. Big enough to incentivise? You'd think so. But as Kim says, it's just not that straightforward. And going back to Kevin, it's the same issue in the subsea sector.
The market predictions are massive. When you look at the global market, it's predicted to be 40 billion over the next 10 years. So it's a very high growth global market that the UK should be, firmly engaged in and actually taking a lead in.
Unlike nuclear, when we spoke to Kevin, he made no particular mention of the timescales being an issue. He was more concerned with the low volume production runs.
That investment is difficult to manage. If you've got a mobile phone that's going to sell millions, there's obviously a very large R&D budget goes into that platform. If you've got a marine autonomous platform that's going to sell, 20, 30 a year, the investment in that R&D is obviously minimal, has to be minimal, so the company can justify a return.
It may well be worth it though, because this technology transfers to a great number of subsea activities. So you have a universal platform that's
sensor specific.
And this would work because
many different offshore users are talking about the same problems in a different language. Regardless of what you're looking for
or at,
you've still got to get the right sort of sensor suite to that part of the ocean.
It's a point not lost on Tom from Thurn Group. They're a company currently doing a feasibility study to establish whether their sensor technology
can also be used to look through the ice. So we'll be looking at whether this technology could be applied to looking up through the bottom of the ice and seeing the strength of the ice and the structure of the ice, which will give you a lot of information about how much of a hazard it is to shipping.
If successful, this is an example of a new commercial application. Back to Kevin, and he's concerned with the wider picture and believes that
if we can get those end users together talking, then we can somehow harness synergies between their different needs and get co-investment into those solutions.
Andrew has another example of how technology can benefit multiple end users, this time outside of extreme environments.
There's no reason why something that picks up a tool very delicately with a precision hand couldn't be used in a care environment to turn a person over in bed, or make sure that in their house they've got facilities because they're not as able. So things like the assisted living market is very important. So there's technologies that we're building in the nuclear industry that you couldn't normally see as being imported into those other industries, but will be, because the underlying technology is there.
This underlying technology will be used in some emerging markets that
maybe aren't that size at the moment, but are due to grow And that's where the potential is, and that's where we want to take those companies where there's great potential for growth in the future. So a typical example would be something like service robots, where traditionally robots in industrial applications would be in a guarded environment, but service robots are starting to be delivered now where they're outside of that guarded environment. So this might be a robot that helps someone lift a heavy weight or hold something in position, or is just there to hand them the right tool at the right moment.
And are there any projections about how big this new service market might be?
If you look at the industrial market at the moment, by 2020, the industrial robotic market is about 45 billion. But actually the service market will only be about 18 billion, but it's due to actually grow over the next 4 or 5 years after that and pass the traditional market. So in other words, service robots is where there aren't many things you can go and buy at the moment in that area, but that's where the market is going to be in the future.
So we know there are technology shortfalls. We know there are huge potential markets. But Andrew suggests that SMEs should still build a solid plan of action.
One of the issues with startups is they have a great bit of tech and they get very excited about the tech. But unless you can link it into something else, so genuinely you have to integrate that technology. Someone might have an articulated hand that can pick up things in all directions like a human hand, but then you've got to attach it to something. It's no good on its own. And then you need a user, an end user, who's prepared to buy that technology. So it's about creating those value chains as well.
He also outlined some of the support that's available from Innovate UK for SMEs.
So what we're trying to do actually as part of our programme is, for instance, in our demonstrator project, is provide that safe living lab environment. So if you're a small company, you want to work on a wind turbine, at height where you wouldn't normally put a person, we're going to effectively hire that test rig, and we have those in the UK. So for instance, the Catapult network can provide some of those facilities, as can academia. We'll allow those companies to come and play on those facilities to test it in a real world environment. So at least they get the chance to do that, because quite often people don't get the opportunity to do that in the first place. So by us enabling them to do that, we can make them accelerate effectively their products and their services.
He makes it clear that collaboration is a big part of developing a business, and Rich Walker echoes this. It turns out
there's a huge explosion of people working in this area. Almost any problem we have, we can find somebody who's like, actually, I'm passionate about that problem and I'm working on it and I'm doing it and you can get this from me. And we really like that because we're big fans of open innovation, the idea that it's much better for you to solve your problem and me to solve my problem, and then we'll exchange systems, we'll sell them to each other, and that way we can both address bigger markets and bigger problems.
And he has a clear plan for how he finds his collaborators.
We're both systematic and opportunistic. So we'll do things like we'll identify that we need to talk to somebody of a certain type in an organisation, and then frankly have a look on LinkedIn, have a look on Facebook, see if we can find people like that. Facebook targeted advertising is brutally efficient. And in fact, that's probably one of the better uses of AI from our point of view at the moment, is I need to find people like this production manager to talk to them about their problems. Bing, done it, great, emailed 100 of them. We'll send them a piece of information that they can look at and react to and respond to.
And as handy as target advertising is,
nothing beats face-to-face networking. Actually sitting down and talking to people. You can Skype, you can go Hangouts, you can talk to them over the phone, but actually face-to-face, sitting there and going, this is what you do, this is what I do, great, let's draw some sketches on the whiteboard, let's pass some bits of paper around, let's work out what we can do together, or we can't, or just go, you know what you do is really interesting. I'll tell Fred, because Fred cares about it and I don't.
What kind of places does Rich find these people?
We go to a lot of networking events, we go to the KTN, does some wonderful workshops where we get together with people from areas near ours and kind of have that one-to-one conversation and can get to a lot of those quickly. We travel around, we go to things overseas because we like to make our connections elsewhere. We do conferences and trade shows. That gets you into places, that gets you known, that gets you understood.
What we've just covered is by no means exhaustive, but hopefully it should give you an overview of the opportunities that are out there. One of the most common arguments around technology, especially robotics, is what impact they have on employment. In short, are robots going to replace us in the workplace? We asked everyone about this, and as you might imagine, the people who are invested in the progression of robotics had a very positive spin on things. They were keen to cite examples like this.
100 years ago, 25% of the population was making food for the other 75%, and now it's like 1%.
And like this.
Nobody mourns for the loss of the buggy whip manufacturer, or indeed the loss of the telephone switchboard operator.
Andrew was keen to point out that job losses might ultimately be beneficial.
I'm old enough to know that we had a typing pool in a factory I worked at. Personal computer got rid of all those jobs overnight. So it did put people out of work. But the computer industry also meant we now have a great deal of software developers. In fact, there's more software developers than there were typists. And by the way, they earn 3 or 4 times as much money.
Despite this positive outlook, they were still concerned about short-term impact. as Kevin from Perceptual explains.
But as a society, I don't think we're very good at dealing with that short-term issue of we've developed something that's really practical and effective, but it displaces all these people, and how do we deal with that? And I do not have answers for that. That's a much broader societal question that I don't know the answer to.
On the other hand, the divers were completely relaxed about all this. As Steve Ham from the Underwater Centre explains.
We've been told in the 70s that diving was only a short-term thing before robotics took over. I see a greater and greater use of robotics, but I don't see a corresponding diminishing of the use of divers at all.
And even when we were talking about relatively modern things like wind turbines, diver Alf Ledbetter had this to say.
When they first came in, I remember going to meetings and they were all going to be diverless, so we're going to do everything with robots. And then they soon found out that they're so slow that they're starting to employ divers, and there's quite a number of vessels and quite a number of companies now just working exclusively in that sort of work.
Alf added that when we eventually get there, we probably need to think about a bigger issue.
When you phone up a plumber and they send a robot around to fix your leak, then we'll probably be replacing people in the water. But I think by that time, the whole of society has to have a rethink, because there isn't going to be any work for anybody, or manual work for anybody anyway. So what do you do with all these people?
Mark Emerton, an innovation lead at Innovate UK, suggests that maybe it's not all doom and gloom.
Even though we may actually have some of these machines start to take over the roles that some humans do, that doesn't take away the fact that actually there's an enormous amount of creativity and engineering and skills required to actually build those systems in the first place. So we will see potentially some skills being displaced, but it may just mean that there's actually now so much more specialist skills. They may be slightly higher paid, maybe have a higher skills requirement, but we're still definitely going to see a human input throughout the whole of the robotics and AI world.
What's important, though, is that we make sure there's a plan in place so that people can do these new jobs.
I remember when I was at school, they were teaching ICT, but it was office-based computing. It was how to use Excel and Word. They didn't teach computer science or machine learning in schools, which they now are starting to do. So more of that transition potentially away from just how to use IT in our existing jobs, and perhaps some more creativity as to what the future jobs might be like. I'd personally quite like to see some quite advanced topics that are currently only really found at a university level in computer science degrees. If we could bring those into secondary school system, that could have a huge impact on skills in the workforce in 10 years' time.
So, we've looked at the state of play and what commercial opportunities exist. But what would happen if we carried on in this vein? What kind of things might we be looking at in like 100 years from now? Is there any way this technology that's just emerging at the moment could be used? Remember earlier when we looked at autonomous vehicles exploring the ice? Well, Tom at Thurn Group told us that this technology could be capable of some really exciting things.
This technology could also be relevant to future exploration of ice-covered planets, for example, Europa.
In case you didn't know, Europa is one of Jupiter's moons. And the reason you should care about that is that, well, why don't I let respected TV scientist Brian Cox fill you in?
Measurements of Europa's magnetic field have confirmed that its icy shell is sitting on top of a salty ocean that may be a staggering 100 kilometres deep.
And this mass of ice and water is of great interest to scientists. And apparently,
NASA has been to the Arctic with autonomous underwater vehicles and remotely controlled underwater vehicles to look at the human-robot interactions when you're working through ice and looking at what's underneath the ice.
So what would they be looking for in the ice? And why would that have anything to do with Europa? Well, you heard a bit earlier from Brian Cox from his series The Wonders of the Solar System. Now, there was another bit we were going to play, but unfortunately our budget didn't run to that. Essentially what Cox said is that the laws of nature and biology may well be universal. So if something's happening on Earth, it could also be happening on Europa. As Stephanie from the NOC explains, there is life in ice.
There's bubbles and little, tiny microscopic cracks and rivulets. They're all over the place. But organisms can live in there, and we've got no way of accessing them at the moment.
Stephanie's describing the problem of scanning from the ocean up through the ice. In his programme, Cox met with NASA scientist Richard Hoover. He took a different route and looked for organisms near the surface of an Icelandic glacier.
You can clearly have bacteria like this in the frozen ice near the surface crust. And the thing that is most exciting to me is that surface crust of Europa has a wide variety of colors that are highly suggestive of microbial life. And so there is a very, very strong possibility that the ice of Europa may contain viable, living microorganisms.
And of course, Brian sums this up in somewhat epic fashion.
It's a controversial idea, but it is a dizzying thought that the mysterious red stains on the surface of Europa could be the visible signs of alien life.
Thanks, Brian. Now, as Mark points out, these rather grand applications of technology always have an impact on what happens here on Earth.
Yeah, well, a lot of people, when they look at extraplanetary exploration, would prefer to focus our efforts and attention on the Earth and actually thinking about solving all of the problems that we have with our own planet first. And I think that's entirely respectable. But one key thing is that a lot of the technologies that we might develop in the space sector, they're going to spill over and be useful to us on Earth. And we've seen that in the past with the space race, that a lot of the technologies developed there are now found in the pocket with your mobile phone, using GPS receivers to get you to work every day. A robotic system that's designed to be able to swim the oceans of Europa and scan the surface ice, for example. That same type of technology could well be employed for exploration around Earth as well. We know that we're having an impact on our oceans because of climate change and pollutants. So there's an opportunity, if we're able to get these highly autonomous robots to explore on their own, to sense and potentially affect their environment for the better, that we might be able to employ some of that technology on Earth in order to help with some of the big problems that we've got with our own planet.
Well, we're just about out of time. I really hope that you've enjoyed this first podcast and that you found it interesting. If there's stuff that you'd like to follow up on, maybe there were some opportunities you didn't know existed, then there are a few places that you can look. First off, innovateuk.gov.uk and the Knowledge Transfer Network, or KTN. Or even just search for the Industrial Strategy Challenge Fund, or ISCF. There, you can find out about all of the funding opportunities and the networking events. We hope to catch up with you on the next podcast, where we'll be addressing another of these challenges. Thanks for listening.